First of all, start with finding the oxidation numbers. How to find the oxidation number. Sorry, don't know. I just got a cough just right now. Okay, so sometimes it could be in your MCQs or just in your section as answer. In your one-word answer, they might ask you a question where they would ask you to find the oxidation number of a particular element in a compound. Okay, they might ask you such a question. For example, they might say, find the oxidation number of, let's say, chromium. Okay, let's say chromium in this particular compound. Does anyone have an idea how to solve such a question? Anyone with an idea on how to solve such a question? Okay, so since no one has an idea, so let me give you now the idea. Find the oxidation number of chromium in this. This looks like chromium permanganate. It's a permanganate ion actually. So if a question comes, okay, if a question comes in chemistry, they ask you to find the oxidation number. The first thing you're going to do, ask yourself, oxidation, what does it mean? It implies that there's a link between the one element and oxygen. Okay, you're attaching oxygen atoms or molecules to a particular element. So now, this chromium has got two atoms. Two atoms. Oxygen has got how many atoms? 7 atoms. 7 atoms. But this particular oxygen, or this particular oxygen that we're talking about, has got a charge. Okay? And the charge is -2. It's a -2 because I've got a -2 this side, a negative charge. So for you to find the oxidation number of this guy, ask yourself, how many atoms of chromium do you have? Hello, can someone just answer me? How many atoms?
2.
2. So you're going to say 2x. How about if there was one chromium? Would have said x. But for this one, you say 2x. Then you are going to add plus. Okay, you say plus. Then you ask yourself this one question. What is the charge of oxygen? What is the How many number of atoms of oxygen do you have? The number of
7.
oxygen of atoms you have? 7. So this 7, inside here, you are going to put the charge of oxygen. So you say -2. Then at the far end there, you still put the charge of oxygen and say -2. Okay? So the first thing we did, we asked ourselves how many atoms of chromium? We said there are 2. So I said 2x. Then how many atoms of oxygen do we have? 7. Then this 7 multiplied by the charge of the number of oxygen atoms that you have, then equal to the charge given, which is 2 negative. So if you continue, you are going to find your 2x, then 7 multiplied by -2 is going to give us -14 equal to -2. So this will be 2x equal to -2 plus 14. 2x is going to equal to 12 over -2 over -2. So your x is going to equal to plus 6. Okay, plus 6. So the oxidation number of chromium in this particular compound is plus 6. Plus 6. Okay. Any question? Let me do another one. I show you the simplest of the simplest way. Okay. The second one we are going to do is this guy here. We find the oxidation number. This is a permanganate. We find the oxidation number of manganese. We find the oxidation number of manganese. So let's ask ourselves, how many atoms of manganese do we have?
1.
So what are we going to say? Are we going to say 2x or x?
X.
Okay, so let me put them together first. So how many atoms of manganese? 1 atom. Okay, how many atoms of oxygen? 4 atoms. What is the charge of oxygen? -1. So the one who was talking to me, you can unmute yourself so that we talk again. What were you saying? What are you going to put, x or 1?
We're going to put X.
Very good. Plus, yes. Then what are we going to do next?
Plus 4.
Very good.
4 times -1.
-1. Very good. What is it going to equal to?
Is equal to -1.
Very good. Any question? Any person who is having who has been left out here? Anyone who has been left out here? Okay. So this is someone wanted to talk. So this will just be the same as x minus 4 is equal to -1. x is going to equal to negative 3 plus 4. X is going to equal to plus 3. So oxidation number of manganese in this particular compound is plus 3. Okay, let's try this one. Let's try this one. We have a sulfate ion. I want the guy to do it. I want the guy to do it. Yes. What is the first thing we are going to pick? Let's pick. We want to find the oxidation number of sulfur. How many atoms of sulfur do we have? Hello? How many atoms of sulfur do we have?
1.
1 atom. No, don't mute yourself. It's okay. Let it be interactive. I like it like that. So sulfur has got good life. How many atoms of sulfur do we have?
1.
1. Don't mute yourself, good life. I want you to speak to me. Then how many atoms of oxygen do we have? Hmm?
4.
4. What is the charge of oxygen?
Negative 2.
Negative 2. So now how are you going to make your equation? Yes, you tell me how we're going to make the equation. Yes? Yes?
X
Yes. Please put in confidence. X, yes?
plus 4
Mm-hmm.
times negative 2 is equal to negative 2.
Is equal to negative 2. Right? So this is going to be x minus 8 is equal to negative 2. So x is going to equal to negative 2 plus 8, and then you're going to get plus 6. Have you seen how we are getting the oxidation number?
Yes.
It's that simple actually. Okay. It's that simple. I want you to try out this one. I want you to try out this one. Oxidation number of. Okay, so let me just give you, let's say 4. Then we're going to say. Okay, you try that one. Try out that one. Let's see. What are you getting? What are you getting?
We are getting 2.
You're getting a 2. Okay, let's check it out. Let's check it out. How many atoms of sulfur do we have? 1. Oxygen, how many do we have? 3. Charge of oxygen, it is -1. So this is going to be x plus 3, the -1, equal to -1. So this is going to be -3 equal to -1. So x is equal to -1 plus 3. So x is equal to +2. Very good. This is the oxidation number for sulfur for sulfur in that particular compound. Guys, now of course if
No.
but you didn't know how to solve them, right?
Yes.
Okay, let's try out another one. The other one which I want us to solve, maybe I bring this one. Let's find the oxidation. How about if it is presented like this? What is the oxidation number? I want you to try out for carbon dioxide. Let's see. What are you getting for carbon dioxide? Hello? You guys, what are you getting?
I think it's 0.
Someone is saying zero.
Yeah, even me, I've gotten 0.
Okay. So how many atoms of carbon do we have? 1. How many oxygen atoms do we have? 2. What is the charge of oxygen in this case? 0. But this guy here is neutral. This guy is not charged. So for something that is not charged, or for a molecule, or for a compound that is not charged, acknowledge that oxygen has got a net charge of -2. Okay? So acknowledge that oxygen is going to have a net charge of -2. So your equation is going to be like this. Since you have a carbon of one atom, it will be X the same way. Plus, then how many atoms of oxygen? 2. Now, the question is, what are you going to put here? You won't put a 0. You will put the charge of oxygen. What is the charge of oxygen? If it's
The
not
charge is 0.
if it's not given,
-2.
if it's not given, it's -2. Remember, put that in your head always. If it's not given, it's -2. Then this is going to be equal to, then you put the charge here, 0 at the end. So this is going to be x plus, this is going to be negative 4. So this is going to be equal to 4 plus. And that becomes the answer for carbon dioxide. Clear? How about for this guy here? How about for this guy? For this guy, find the oxidation number there. What are you getting?
I'm getting +2.
Positive 2. So let's check. How many atoms of carbon? 1. Atoms of oxygen? 1. Charge of oxygen? 0. But we know that oxygen is going to have a particular charge somewhere because it's neutral. So this is just the same as x plus, then this is going to be a 1, open bracket, negative 2 equal to 0. Okay, we have taught. That is how you solve it when you're dealing with oxygen. Any question? I want you to try this one as a task. As a task, let me give you this one. Okay. Find the oxidation number of this sulfur in sulfur dioxide. Just 2 minutes. 2 minutes, 2 minutes, 2 minutes. What are you getting? What are you getting?
+4.
Yeah?
I've gotten a +4.
Positive 4. The other one, what are you getting? Good life. Chimuka, what are you getting? Okay, so we have 1 sulfur atom, 2 oxygen, the charge of oxygen, sorry, the whole charge of oxygen for this particular compound is 0, but we know that oxygen is going to have a net charge of negative 2. So this is going to be x plus, atoms we have 2, negative 2, then this is going to be 0. So this is going to be x plus negative 4 equal to 0. So of course x is going to equal to plus 4. Who found plus 4? Sarah Perry, your mic is on. Sarah, your microphone is on. Who found what's this? Someone found plus 4. Okay, it's okay. That is the correct answer. Now, how does it change? How does finding oxidation number change if you are dealing with hydrogen. For hydrogen, remember that hydrogen has got a positive partial charge, like this. So instead of having -2, we shall be having -1. Sorry, +1 in hydrogen. So whenever you see they want you to find the oxidation number and there is hydrogen in there, don't even waste time. You will be adding 1, okay, depending with the number of atoms given. A very good example, we are going to have an atom which is going to, sorry, a compound which is going to be neutral. So I want to find the oxidation number for sulfur in this particular compound. The same concept, let's ask ourselves, how many atoms of hydrogen do we have? Sarah. Atoms of hydrogen. There are 2. What is the number of atoms of sulfur? It's just 1. What is the charge? For this whole thing is neutral, so it's 0. So since it is 0, here we know that what is the net charge of hydrogen? It's going to be +1. That's the net charge of hydrogen, +1. It's here, you can't just see it. So you say X plus, then the same thing. Okay, we had 2 atoms multiplied by +1 equal to 0. So this is just the same as X multiplied by this guy is going to be +2 equal to 0. So this one is going to have a net oxidation number of -2. Simple. That's how you find. Hello? Any question? Any question, Sarah? You just recently joined? Sarah. I'm saying any question? Okay, no question. So I'm sure you understand how we were solving these questions. I think this part is now very simple now. I think most of you are now able to solve these questions. Good life, are you able to solve my oxidation number after having learned this?
Yes.
Okay, let's do task. Find the oxidation number of calcium in this particular compound. What is the oxidation number of calcium there? You also do for this guy here. What are you getting? What have you found for the first question?
The first question is -2.
Okay, -2. How about others? What have you found?
The first one, -2.
And then the second one.
-1.
-1.
So let's find the first one first. So calcium 1, hydrogen 2, charge 0, but we know that hydrogen is going to have a net charge of +1. So this is going to be x plus, yes, 2 multiplied by +1 equal to 0. So -2. Okay, correct. Then for this one, sodium 1, hydrogen 1, charge 0. So this is going to be x plus 1 multiplied by +1 equal to 0. So x is going to equal to -1. Correct. You've understood the concept. Now let's try to do just one more. How about if, for example, a compound is containing both hydrogen and oxygen? How do you treat it? Let's say they ask you to find the oxidation number in sulfuric acid. How do we go about it? The same concept, we try the same concept. Let's check how many hydrogens do we have. 2. Sulfur, how many do we have? 1. Oxygen, how many do we have? 4. What is the charge for this particular compound, the whole of it? 0. But we know that there's a +1 here. Don't forget, there's a -2 here. So, what you're going to do is the same concept. Since you have one sulfur atom, you will put your X there. Okay, you will put your X, then you say plus. So here you've got 4 oxygen atoms, so it will be 4 oxygen atoms. What are we going to put inside there? What are we going to put inside?
-2.
-2 plus. Then we do the part for hydrogen. So we have 2 atoms. Then what do we put inside there?
+2. +1.
+1. Then this is going to equal what? Hello? This is going to equal what?
0.
0. Then you do your calculations. So this is going to be negative 6 equal to 0, and your x becomes your plus 6. Any question there? So basically that is what I want. Okay? That is what I want. When they ask you a question, when they ask you a question in the exam, don't babauka. Don't make a mistake, because it's very simple actually. This is how you do it. All of them, just use the same concept that the mentor has taught you. You'll be able to find almost any question. I want you to try out this one. Find the oxidation number of phosphorus. Find the oxidation number of phosphorus in this compound. Finding the oxidation number of phosphorus in this compound. I'm just giving you about 2 minutes. Oxidation number of phosphorus. What are you getting? Let's be quick. Actually, 30 seconds. 30 seconds. 30 seconds. What have you gotten? Okay, so we solve.
We are getting positive 5.
Let's check it out.
Positive 5.
Okay, okay. So everyone is saying positive 5. Let's check. Hydrogen, how many do we have? 3. Phosphorus, 1. Oxygen, 4. Charge of the whole thing, 0. So, but we know that there's a plus 1 here. There's a minus 2 here. So, of course, we do the same thing. X plus is going to be 4, then negative 2, plus this is going to be 3 plus 1 equal to 0. So this is going to be minus 8 plus 3 equal to 0. And then here we're going to get a minus 5 equal to 0, and our x is equal to plus 5. Don't forget to put the plus, the minus. Those are charges. At least you're able to show the examiner something. Okay, I'm sure we've now understood this part. Sarah, clear? Okay. All right, so that is how we do that part. That is how we solve such type of questions. We go back to our topic. There's a question which I wanted us to do. Okay. We go back to the things that we're doing. So this question was saying, a 23.8 liters balloon is filled with 88 grams of carbon dioxide at 15 degrees Celsius. What is the pressure in kilopascals? So we have a 23.8 liters balloon which is filled with 88 grams of carbon dioxide at 15 degrees. What is the pressure in kilopascals? We want to find the pressure in kilopascals. In the data, we have been given the mass of carbon dioxide, and they are saying it is 88 grams. We just want to collect the data. And then we have been told that the temperature is at 15 degrees Celsius. We have been also given the volume 1 to be 23.8 liters. Okay, so looking at what we have been given here, they want us to calculate the pressure in kilopascals. Which formula are we going to use? Looking at what we have been given. So, looking at what you have been given, the best formula you are going to use from what we learned last time is the formula for the ideal gas. The formula for the ideal gas. I want you to give me that formula, guys. Can someone give me the formula for the ideal gas?
Um, pressure 1
Uh-huh.
time, times volume 1
Uh-huh.
divided by temperature 1.
Ideal gas. If you say divide by temperature 1, what are you going to do with this mass? Hello? What are you going to do with the mass? So this formula is not holding. I want the formula for the ideal gas. Anyone who is having the formula for the ideal gas?
It's pressure times volume is equal to number of moles
Very good. Pressure times the volume is equal to the number of moles. Yes.
times RT.
Very good. Have you seen that whatever you're having is going to fit? So whenever you are dealing with this topic, no wonder I was telling you, so this topic is simple. If you collect the data and you know the formulas, what they want you to calculate is just the pressure. So you can even say over V, over V. So you can cancel out, you remain with your P equal to number of moles RT over V. Then you can ask yourself, what is the number of moles of carbon dioxide? We can calculate them. We know that number of moles is equal to the mass over the mixture. That's what we learned in our previous sessions. Carbon dioxide is 1 multiplied by, what is the relative atomic mass? 12. So this becomes 12. Then oxygen is a 2 multiplied by 16, and that becomes 32. Altogether, we are getting 44. Okay? 44. So, you can say that number of moles is equal to number of moles of carbon dioxide is equal to, what is the mass given? It is 88 over 44. Number of moles is going to equal to what? 2. Have you seen? Then you say pressure is going to equal to, so since we're using liters, which constant are we going to use? We are using liters.
We are going to use 0.0821.
Is it the one which is having liters or deciliters?
It's the one which is having liters.
It is the one which is having liters. So
Yes.
give me, what is it?
0.0821.
0.0821. Then what is the temperature? I want you to help me convert that temperature in kelvins. What are you getting?
It's giving 288.
288. Then divide by the volume. Let's calculate. So 2, this is going to be 2 multiplied by 0.0821. Then 288 divided by 23.08. 23.8. And I'm getting 1.98. Okay, 1.8, 1.98. 1.98. Now I want to ask you a question. The one who is reading, what was the pressure? What was the pressure? What was the pressure units in this one for 0.028, 0.0821? What was the units of the pressure there? What was the units? Were they Pascals or they were ATM or they were what?
Oh, they were ATM.
ATM, right? They were atmospheres. Okay? They were atmospheres. So now you need to use a conversion. What you have found here, this pressure found here is going to be in atmospheres. Have you seen how tricky this thing is? This that you're going to find here is going to be in atmospheres. Why? Because you used you used a the one which you used had its pressure in atmospheres. So you use now a conversion factor. Okay? You use a conversion factor where you say 1 atmosphere is going to equal to 101,325 pascals. Okay? 101,325 pascals. Then 1.98 ATM is going to equal to X. Let's multiply. What are we getting? If you multiply by that number, 101,325, I'm getting something like 101,325. Then since it's kilopascal, you divide this by 1000. This was in pascals. Now kilopascal, you divide by 1000. And our final answer becomes 101.325 kilopascals. Any question on that? Hello? That is how you calculate for that particular question. Okay? You can, conversion units, conversion factors are coming. There is one question which I was interested in on Dalton's law. This question was saying a
First,
mixed. Hello.
first repeat the calculation. How come you are getting the same figures when you multiply 101,325 times 1.98?
What are you getting there? What are you getting there?
I'm getting 2,000. 2,623.5.
Okay. At least you understand the concept. What I'm doing. That is what is the most important thing. So this is a 12,000. Thank you so much for the correction. This is a 2,206 23.5. Then we divide this by 1,000. These are pascals. And we get a 200.6 kilopascals. All right, thank you. So that is just how you do it. This question was saying a mixture of 2.0, a mixture of 2.0 moles. We have a mixture of 2.0 moles of hydrogen. And then we are also going to have 3 moles of ammonia, 4 moles of carbon dioxide, and 5.0 moles of nitrogen. They are saying it exerts a total pressure of 800 to. Question: calculate the individual partial pressure we find the individual partial pressure of hydrogen, ammonia, and carbon dioxide as well as nitrogen. Then the second question is saying we find the total partial pressure. Total partial pressure. We find the total partial pressure. Okay, so we do the solution. I think I already started. Open where we left on Dalton's law. So remember, I said when you want if you want to make Dalton's law very simple, just the concept is if you want to find the partial. Okay, let's do the first partial pressure. We want to find the partial pressure for hydrogen. The partial pressure for hydrogen is going to be the number of moles of hydrogen over the total number of moles multiplied by the total pressure exerted. That's all. That's what I implied in the previous video. So let's first of all get the total number of moles. So total number of moles, let's add everything. We have a 2 plus a 3 plus a 4. What are you getting if you add everything together? 2 plus 3 plus a 4 plus a 5. We are getting 14. 14.0 moles. Okay. Then this for us to find the partial pressure for hydrogen, you get the number of moles of hydrogen, you divide them by the total, which is 14, then you multiply by the total pressure, the total pressure exerted, which is 800 torr. Whatever you get, that becomes the individual pressure uh, of hydrogen. Okay, so I want each one of you to pick one. One can find for. Let me give you. Okay. So, gift. I want you to find for ammonia. Then, Wutoy, I want you to find for carbon dioxide. Quickly, quickly, quickly. We just work out this together. We finish. So 2 divided by 14 multiplied by 800, we are going to get 114.28 torrs. Okay, so the one who is finding for ammonia, tell us. The one who is finding for carbon dioxide, tell us. Let me also find for nitrogen again. Partial pressure of nitrogen, number of moles. This is going to be 285.7 torrs. What have you found for
ammonia, it's given 171.4.
171.4? And then for carbon dioxide, what are you finding?
Before I did not get where the TN, where you get your TN from.
Tn is the total number of moles.
Okay.
Hello?
All right.
So
Okay.
what are you finding? Utoy. Okay, the other one you can calculate it also.
For carbon dioxide, 228.5.
Okay, good.
228. 0.5.
Okay, two. So you have calculated individual pressures. Now you can find the total partial pressure. So total partial pressure, we can just add up everything. 114.28 plus 171.4 plus 228.5 plus 285.7, and this gives us 799.8 those. Okay, so I just wanted to maybe just find this question for you, so that in case there is need for just for the sake of learning, yeah. Okay, I'm sure we have understood what we wanted to learn today. Oxidation numbers and practice questions on what we, just for the sake of revision and stuff. So the next time we come to meet, I'll go directly to Graham's law. If these people are going to add a topic, we may do it. But as at now, at least we are up to date. We don't have a lot of things to learn. So it means that at least we can do some revisions. Make sure you send the tutorial sheets we go through. Am I helping?
Yes, very
Very
much.
much.
All right, thank you so much. I'll upload the session.